Hello and welcome to NRM 5404 summer semester class. In the previous exercise, we learned about Google Earth Engine interface. We explored some basic data types and we differentiate between client-side and server-side functions. We loaded ortho imagery, clipped within the region of interest, and displayed. In the first part, we will learn basic function in Google Earth Engine. In the second part, we will ingest our data into Google Earth Engine Asset tab. And third, we will learn in detail about spatial reducers in Earth Engine. And in the final part, we will cloud mask Landsat images. Okay, let's start with the first one. Here I have already opened Google Earth Engine code editor. In this video, basically, we wanted to know about the different feature collection, the data. Normally, there are a lot of data as we saw last time. We need to understand what feature collection, image collection, and geometry. These are the three things that we need the most. And we learned already how to create a geometry by ourselves. And if we have our area of interest, we will learn how to ingest that data in Google Earth Engine in the next video. And simply, feature collection is the collection of different features. For example, feature collection could be the combination of point, line, and polygons. And we'll learn about this data just in a bit. And the image collection is the collection of image, and this image collection depends on the type of image products. So in the geometry, we can declare the geometry type just using the function ee.geometry.point for point, .polygon for polygon, .multipoint, .line string. There are other geometry type. Most of the time we need only point and polygon. Polygon data we can digitize in the map, but also we can define the x and y coordinate or latitude and longitude of the location and then put it in the list. For example, here variable polygon is defined with this extent. And finally, we need to learn about how to display the image or feature we have on the map. For that, we already used this function before, which is map.addLayer. And sometimes if we have a lot of data and then we wanted to zoom in a certain portion to avoid scrolling the mouse again and again, we can define the zoom level as well as we can set the center. For that, we can use map.setCenter function. So here you can see everything is in the green color, so I have commented out everything. When you run it one at a time, you can uncomment it. So far we have already covered this part, but I just wanted to stress the fact that we need those functions every single time we use the Google Earth Engine. Normally in the Google Earth Engine we don't apply a lot of function, or we don't manipulate our feature. And sometimes if we need, probably the area would be the most important feature or the attribute that we will be more interested in, whether we can calculate in appended at the end of the feature collection, or we can simply calculate the area. So feature collection is a collection of different features, as I mentioned earlier: point, line, and polygons, and combination of those. It could be only points of different themes, it could be lines and polygons, and it could be a combination of all those three at a time. So normally we need those features to define our region of interest, and most of the time we use a political boundary as our area of interest. If we really need the political boundary, the tiger dataset would be of our interest. Here with this line of code, now I'm going to uncomment some of the function we need here. So first I will uncomment this line so that defines where I wanted to zoom it, and this variable can be created from here. Let's say we wanted to zoom to logbook. We can go and click add marker pen and simply click, and this creates the geometry feature for us. And we can go to inspector tab on the right side and then click on this point to understand the location of this point, and then we can simply copy and paste that X and Y location. Here the 6 is the zoom label, and then I can delete this variable from here. You can keep it. Here if I run it, it will only zoom to that label, which is 6. If you can increase and decrease this number, I guess the value can be between 1 and 24. I am not quite sure. I think it's 24. Let's type 25 here, and then what does it say? It throws some error. Yes, 0 and 24. For now, I'm happy with 6. So let's load the tiger data, and tiger data can be searched from here. Simply type tiger and then US Census, let's say 2018. If we click on the tiger census 2018 data, and this is the collection snippet name, and this is what I am using in my script. In the table schema, you can see basically this is the equivalent attribute table. We have a lot of variable. Since we are more interested in the Texas and the logbook, let's find out those variables that we could be interested. State FP, state FIPS code, that could be our interest. There should be county FP to filter the logbook from Texas. And there is some other information. So I'm gonna close it. So that's what I have defined here. I'm giving the name US Tiger Map, and then now we can start filtering it. First, I wanted to filter only Texas from that whole map, and then just add that. It will probably take some time. Let's run it, and until then, okay, it's immediately start loading. It's so fast. Now what I wanted to do is sometimes we need only the map of Texas, so we can use a lot of the function in GIS that we use to reduce either intersect, merge, union. All those functions can be used. Here I have an example of union. So here now I have a Texas counties data, and I wanted to use that county's information and then union them. So what could be the results? And let's display that. So basically what it does is it dissolves all the boundaries of counties and then give us a big single feature. And I give a name here, Texas outline to see, and then we can remove this and then see now this is the big object, single object. This line of code extract the extent minimum and maximum of latitude and longitude of Texas from here. This is what the crop function was doing in R. So let's see. Let's calculate the extent, and as I mentioned in the previous exercise as well, as of now there is no way to run only single line or the number of lines together. All we have option is to run everything at a time. So that means every commented lines are ignored and only those highlighted portion are running. Okay, well, it's working. We can add actually that extent layer, which we already know what is going to be the answer. So now we can go ahead and then filter only within the extent of Lubbock. So Texas counties, we already have Texas counties here from the Tiger map, and we can filter that. For that, filter is the function, and in the filter we use the filter equals to county FP, and the FIPS code for county of Lubbock is 303. It threw some error, geometry error for some reason. Probably it was taking too long time. So now we have the Lubbock, and then we can add it and then run it. While it's running, we can go and understand all this part of chunk. So there are two ways to comment, at least in Google Earth Engine. There are normally multiple way of commenting. Here, if you wanted to comment several lines together, you have to start the line, the beginning line with the forward slash and then asterisk, and then end wherever you wanted to stop commenting with the asterisk and forward slash again. If we have the geometry only to get the centroid or area other feature, we can simply run dot centroid dot median or any other function here. But this is not only the geometry but the feature collection of other geometry type, and when we reduce it still gives us the feature. So in the feature we have to apply the function. So how do we define the function here? The function definition always starts with the name function and the name of the function that we wanted to give. Here in my case I wanted to extract the center of the geometry, and then I give a name, get center, and the input will be the feature, and within that function I wanted to calculate the centroid of the feature and then return that as a name center. To apply the center, I wanted to give a name L center. Here I wanted to find out the center point of Lubbock geometric center, and for that we need the map function. So Lubbock dot map, because we already have the Lubbock here. We extracted the Lubbock, here the red. We wanted to apply the map and the function name, which is get center. Now we can add that centroid. And if we run everything, I don't know why it was throwing some geometry error here, but it should be fine. It was still showing us what we really wanted. So we have all the layers we displayed. We have Texas counties, Texas outline, and then bound. The extent is a bounds, and then Lubbock County, and then center point of Lubbock in green color. I think I gave a green color here. Sometimes I use the hex color, sometimes just the color name. So the video is getting longer, so for now I wanted to stop here. Here's the bonus function to get the same thing, or filter the Lubbock County from the tiger map in one go. Okay, I'll stop here and then I'll see you in the next video.